Looking at the vita of Jelena shows me one thing, that we don't have much in common, but for both of us, it's the first sec4dev conference, at least, and I'm very happy to announce her talk. Jelena Milosevic is a senior data scientist at Mondi Group, where she supports the digitalization within the industrial manufacturing business. She works on end-to-end design and development of machine learning-based solutions that are suitable for production environments. Jelena holds a master's degree in electrical and computer engineering from the University of Novi Sad, a PhD from the Faculty of Informatics at the USI Lugano in Switzerland, and she was a postdoctoral researcher at the Institute of Telecommunications here at TU Wien. She worked on detection and prevention of cyber attacks in network traffic using machine learning methods. So, to sum it up, Jelena has lots of expertise in machine learning, security, and embedded systems. That's why we're really looking forward to her talk now. And so, Jelena, please welcome with me Jelena Milosevic talking about best practices for machine learning in security. One moment, we can't hear you right now.
Very happy that there is at least this possibility to present. So I hope you will ask questions, and I hope we'll still get like a bit of the nice energy that we usually see in conferences. And I'll try to go through this with, let's say, enthusiasm, so just to compensate for the lack of physical presence. So I said, my talk today is going to be about best practices for machine learning in security. I hope that you can all see me well, hear me well, and that you are also enthusiastic about this topic. And just like a short recap about who am I, it's pretty much what we heard already. Yes, I am currently senior data scientist. Before I did a PhD in Lugano, and then through the project I was working there, it was essentially the detection of mobile malware. I found a very nice position at TU Wien, then dealing with detection of attacks in networks, in communication networks. So for me, it was a nice flow to come to Vienna, a reason to come here, where I so far enjoyed quite a lot. And yes, so just to go now a bit more into my work with machine learning and security, and essentially motivation, why am I discussing this topic? During my especially academic experience before, I did a lot of topics connected to malware detection, anomaly detection, and essentially failure prediction. In addition, in the last period of my research, essentially in the postdoc times at TU Wien, I started looking more into this other topic, the rising topic of adversarial machine learning and essentially security of machine learning. And there I researched for some time what are the attacks that exist against machine learning, what are some common defenses, and also at that point it was on the rise the topic of explainable machine learning. With its new methods and so on. And what I find very interesting is that when we combine these two topics with specific application domains, when then specifics of these application domains kick in. So for example, if we talk about embedded systems, then we usually have a constrained environment in which we don't have maybe enough battery to support very complex machine learning models. But in any case, even in those scenarios, we care about security. So how can we do all of this to the best possible way? And when we combine these machine learning approaches with these application-specific things, then very interesting things pop up, and it's very nice to actually do machine learning for these domain-specific cases. And so apart from just using machine learning for security, it's already 3 years work within Mondi, which is essentially a manufacturing company. And now we use machine learning in other topics, mainly the topic of predictive maintenance, but also on all kinds of predictive modeling, optimization of productions, and so on. And before this, I was also working with ECG signals, face emotion detection, and so on. So I have a lot of experience with different domains of machine learning, but security remains still my favorite one, I need to say that. Okay. So now coming back to the talk, what we are gonna cover today is essentially first introduction about AI, why we need it, why we use it, then going through AI and security, why it matters, why we discuss this topic, and finally, what are the advantages of having it, and also what are some disadvantages, possible problems, things that we need to look at. And then in the second part of the presentation, I'll gonna talk quickly about pitfalls, the common problems that can appear when using machine learning in security, and we'll suggest a couple of best practices to have in mind in order to avoid these pitfalls, finishing with then takeaways of the talk. And now going into AI, and essentially what it is, well, I think we so far all know about its importance and how widespread it is. And just to name a couple of examples where it's so far successfully used is this things like probing the cosmos, looking into proteins. So it is essentially a tool, a way of learning, a way of knowledge representation that is touching almost every aspect of our life. And it is still something that is application specific and problem specific in most cases, but there are already some domains in which it goes above human performance, like computer vision tasks, recognition tasks, like, for example, recognition of numbers, like what is it, 9, is it 10, whatever. This is already better done with AI than with human performance. Finally, we do use it more and more, and AI is more widespread, and we rely more and more on it in our daily life, and as a kind of support for all things we do, both in business and in personal life. And at the same time, that our reliance on it increases, we somehow trust it more, but trust in AI is still a relatively new topic. And it is something that is essentially consisting of AI transparency, so essentially knowing what AI is doing and how it is trying to do this thing, is then touching the topic of security, fairness, and bias, essentially. And all these topics are extremely relevant, but also very new in the domain of AI. So they are all currently, let's say, there are open problems within each of these. There are many advances, but also a lot of awareness needs to be placed into understanding, can we really trust AI, how much, and is everything we do with this okay? And now I'm moving on into AI and security. And as I just mentioned, AI has all these possible trust problems, and this makes it challenging, but it is particularly challenging when we talk about AI and security, because now we are talking about environment in which there are inherent adversarial threats. And this brings everything into one another dimension. And this is the environment in which we operate, but in any case, we still rely quite a lot on machine learning and AI, and it's essentially a useful thing. And why is it the case? Well, essentially, we don't have other way to analyze huge amounts of collected data, other way like this. Other possibility that AI brings us is to essentially understand the complex patterns that go beyond the rules that we can write to check, is this present, is this present, is this and that present. So the scale of what AI can discover in data is much, much bigger than what we can do otherwise. And this is essentially a promise for security to go beyond this just, let's say, signature matching and like looking at into slight variations of something. But this is now a way to very early detect potential variants of attacks, like of new attacks, of novel attacks, not anymore just slight variations and not anymore looking just into rules. So this is the reason why we do it, and essentially we already use it quite a lot in security in many domains. The most prominent one is the malware detection domain, but definitely we also use AI for phishing detection, spam detection, network intrusion problems, vulnerability discovery, and lately also about in the domain of abuse detection, where we try to detect, let's say, fake accounts, fake profiles, logins, all kinds of things that could deviate from expected behavior. And again, while AI is definitely beneficial, at the same time, it is also essentially a software that can have some problems and vulnerabilities that can be exploited. And this is now the rising awareness in the last couple of years that same as any other software, AI has its own problems, but in addition to those, it has also what is called inherent weaknesses that come from the algorithmic and data-driven nature of these systems. And finally, this is essentially a black box approach. So we have ways to check this and that, but we cannot really say what is that is happening with this model in depth, especially now when we are talking about maybe millions of parameters that we use in calculations. And for this, there are essentially two categories of things to have in mind that I'm going to cover in the rest of the presentation. And the first category is the attacks against deployed machine learning models. So we do whatever we can, and then we put our machine learning model in deployment. What can happen then in terms of attacks? This is the first part. And the second part, I'm going to go into the pitfalls in the system design. But now stay with me with the first part. And essentially what happens now with, if we have machine learning model, is that at the beginning we do something that's called training. We can, in this part, we have a data set with, let's say, positive, negative samples, malware, benign traffic, or things like this. And we then try to essentially see which features represent the best this data set, and we select a couple of algorithms, we tune them, we try to see which one is the best, and then we say, okay, this one is the best for me, and we essentially go into deployment step with this algorithm. But what can happen then is a set of problems with respect to our known SIA triad. And these problems are essentially new. There is, let's say, a couple of years now awareness of these problems, and people work on this actively. I'll mention quickly the problems about model stealing. So model can be leaked. Through model, we can release confidential information about which data was used, maybe even was certain person participant in certain studies. So there is a lot of leakage of data there, but also in terms of integrity, there is an evasion attack that I'm going to now cover in more details. And then in terms of availability, what can happen is that through essentially discovering a way how to send to the model samples that are benign, but appear maybe like some attack, one can essentially cause problems on availability of the system, because after so many false positives, one already says, okay, the system doesn't work anymore, but it's essentially just because it is in the attacker environment where attacker is actively sending intentionally traffic to cause these false positives. But again, these are all the problems that are active in this area. Today, I'm gonna just tell you more about the evasion attack because it's so far the most prevalent and the most understood and the most discussed attack in the research topics. So now we are back with this standard pipeline, training, deployment. Fine, that's okay. And the point is that with this evasion attack, what happens here is that essentially an attacker is able to craft a certain attack or representation of attack that our system sees as completely benign with high confidence and marks it as benign, but in fact, this is a real attack. And for this reason, this is called evasion attack, and this such sample that is able to disguise as completely benign while not being it is called adversarial sample. And this is a problem, but this is especially a problem in the physical world. And so, for example, now when we have more and more self-driving cars and more autonomous systems, what can happen with this adversarial sample is that, for example, we have a stop sign, and at the same time, human clearly sees this is a stop, machine learning system clearly sees this is a stop. But now the attacker is able to maliciously modify this stop sign in such a way that for us humans is super clear is a stop, but machine learning system now thinks, no, this is with high confidence, go ahead. And things like this are a big problem in the community, and people try to protect as much from this, but these are also inherent properties of machine learning models. And what is also bad about these attacks is that in recent years it was shown that these samples that we see here, these modifications to a certain input to intentionally get something else, are something that can be automated. So one doesn't need to spend now a lot of time in order to create these malicious samples, but rather it is something that one can just use existing tools and get it very quick. So this is a worrying part of the problem. And one another thing is that it was shown for the property called transferability, that if machine learning system on the back is of a different kind, so for example, if I develop such attack for a deep neural network and the system, machine learning system, is maybe based on now SVM or tree or anything like this, there is a high probability that this attack would still work. So this is now let's say the problem in this community, that first we can automate this, second they work for many cases. But yes, so this is and this is how the field developed. So here I have a couple of attacks. So there were first attacks FGSM who were requiring, let's say, large perturbations, images that they were getting in terms of adversarial samples were clearly distorted and so on and so on. But with time, this also the sophistication of these attacks became better, and final versions even now have minimum perturbations that are not visible to humans anymore. And so, of course, it comes with a higher computational cost, but there are works on this topic. And what is here interesting to say is that, and I mentioned there are ways to do this in an automated way. Yes, these are all the tools that allow to do one or the other way in an automated way. So these things can be done, but of course the whole community is at the same time working on defenses against these attacks. And this defense part is still open problem in this field, but of course there are many things already happening. And just to quickly go through them, just for your awareness, that they exist. There are already a couple of ways to protect from these attacks. One way is natural way to say, well, if I can generate these samples automatically and I can know, okay, this will be adversarial sample, well, let me generate it in my training time, include it already in my model, and train my model to essentially cope with that. And this is the topic of adversarial retraining. There are others. I'll not now go into the details how and why all of this works, but they are also, each of them has some problems, some advantage. So this is again considered not completely resolved problem, and it remains still a question: how can we efficiently deal with all of these attacks? And so in terms of these attacks, when they appeared some years ago, they were really heavily driven on images, like images, perturbations, do this, do that. And people at that time perceived it not so serious, because the topic of images, okay, fine, if I misclassify. But what has happened after this is that many research papers came after and showed that many machine learning-based systems are actually prone to these problems. And also within the domain of security, we have seen papers that analyzed malware detection systems and have shown that, yes, they can craft successfully these evasion attacks that are able to avoid the given malware detection systems. So this is the part of, okay, it was pictures, but then we have seen it in other systems. And now recently there is also a new paper that showed that essentially these attacks, evasion, also poisoning is another category, are coming also to the real production systems. And within this paper, then the authors discuss what is the scale of this, how many attacks they observed, and so on. So we are not going to go into this, but the point here is just to say that the more time passes, the better we essentially understand machine learning, the more we analyze it. We do understand that there is also this problem with its inherent properties and how it works, how it can be evaded. And we are adding more and more knowledge about what is it and also how to defend from this. And this is important to have in mind as a practitioner of machine learning. Fine. So that was the first part, and now I'm moving on into the second topic of my talk today. And the second topic is essentially covering not anymore the attacks, but just saying, well, me as a machine learning designer, system designer, what should I look at? What are the good things to do? What should I avoid? And this is the reason we do all of this, because we essentially want to avoid unrepresentative results from machine learning, unreliable predictions, overestimated predictions, all kinds of problems. And I see that now the time is running out, so I'll now not go into each of this, but I'll try to convey to you what are the main hints that you should have in mind, and just main things that should be avoided or should be done. And basically this part I separated in different segments of similar to what the machine learning pipeline is, where at the beginning we have data collection and labeling. And this is essentially a crucial step in machine learning, because if we don't really do this well, everything that comes after is not gonna work out. And here is really important to spend enough time to understand the data and gather essentially as representative data as possible. And within the context of security, this is sometimes very hard, because the data we work with in security is really publicly available, small data sets, internally sensitive, so no one is really keen on sharing. But it is really, really important to be aware of importance of having a good data. And finally, to be aware of importance of good labels. So within the last years, there is a big trend of, oh, the more data, the better. Yes, that's fine. But it is crucial to essentially have good labels. And with good labels and even smaller data sets, we are able to develop much better models than with just some data, some labels that we don't know what is it there. So this is important topic, is really important. Now, when I move on into the next step of machine learning pipeline, where we have essentially system design and learning, what happens here is that many people are essentially trying to immediately go into some model that does something and so on, without essentially making first a certain baseline. So this is a common pitfall, and this is important to do. So it is very important to first understand the problem, either through surveying the literature or running some simple rules-based system or running very simple methods and so on, just to understand what is the baseline for this, what is the baseline, let's say, accuracy or metric or performance for this problem I'm looking at. And this is essentially a fundamental step in developing a model later on that is not too complex and not too weak or not too underperforming for the problem we have at hand. And so far, my experience with security problems of different kind is that we don't really always need deep learning. Also, because of the dependency on data, we usually don't have so much data. So it is sometimes very beneficial to check also other methods coming from traditional machine learning. And especially random forest methods or gradient boosting methods are those methods that are historically proven very, very successful on structured data like we commonly have in security. And this is really important in the design step. Next thing that is really important is to essentially understand the features, understand how many we essentially need, and only consider those that matter, primarily with the goal of already having the whole system of design in mind and not having to essentially later deploy something with thousands of features that you need to maintain, which we'll discuss next as a complex thing to do. And then finally, the part that is important sometimes is to consider not just one model, but multiple models. And through this ensemble of models, essentially achieve better accuracy, but also in a way, better resistance against adversarial attacks. So this is important thing to have in mind. And finally, it is fundamental to include in this step also explainability techniques that are recently being developed more and more, and there are easier ways to use them. For example, in Python, there are things like LIMO, SHAP values, and so on and so on. And all these techniques allow us to understand, okay, is my model doing something reasonable? Is it reasonable that it uses these features to make these decisions? And only through that knowledge we can understand if we are building something useful. Finally, the next part on this is performance evaluation is another crucial step. And here it is really important to develop metrics that are measuring how useful this model is in practice. So as data scientists, we commonly operate with root mean square error, things like this. But when I go into production and when I put this my model into production, people really want to know, is it efficient? Is the time that is saying representative to the real problem? How much time we wasted? So there are all these practical metrics that for people who use the models are much, much better than my root mean square error that people don't understand. So it is important to somehow connect accuracy of the model with its usefulness in practice, just that in this way we can have a feedback of, is this model doing well or not? And the next topic here is about how we develop methods, and essentially the fact that many of the results we create are non-reproducible. This is, of course, a big topic in academia, where now we see more and more papers also with the source code published, with dataset published, but this is still developing. It's still not fully reproducible, and there are estimates that millions of euros are actually being wasted through the fact that we are not able to reproduce results quickly, but everyone is then again starting with its own data set, with its own computational resources, with its own energy being spent and so on. So this is important in academia, let's say, but also within industrial settings. So if you cannot publish this work, then at least it's very good if you engage openly about what you develop, how it works and so on with your teammates. You can discuss feedback, you can present results, and you can aim for having it reproducible, at least within the scope of people who are allowed to access this information. And this topic now being it's so important, there are many tools developing that support the process of, let's say, tracking the experiments, storing what was used, how it was used. There is also this DVC is data versioning control that allows us also to now version changes that we do on a data set. So there are many efforts in this part, and as a practitioner is very important that we use these tools correctly. And finally, this is a very common topic that happens, common pitfall, is that we get overestimated performance of our machine learning models, and we say, oh, model is performing very well. Then we put it really in the real system and we see, no, it's terrible. So what do we do now? And the number one reason of this happening is that people don't really separate training and testing data properly. And there are many ways in which this is the information from tests subtly enters the training data we use, and thus the evaluation we do becomes non-representative. And only when we put it in production, there we have representative data, but then we already spend a lot of resources. And another topic here is that given that within security, we usually have highly unbalanced data sets, accuracy is not a good metric, but it's still the one that is most frequently used and reported. And this creates, again, this overestimated sensation of, oh, okay, my 99.9% correct, fine. But if you had 0.1% of attacks in your data set, we don't know anything about how did your method perform on those. So it is really important here to be aware of the problem and use multiple metrics to describe solutions so that we then can aim for better ones before they are deployed. And now the final part of the deployment, this is now where everything comes down together, is that when we essentially, what happens frequently is that we don't really consider a suitable threat model for where the machine learning model will run. So there is now a completely different scenario if our model is going to be somewhere where it's exposed to, let's say, external users, where people can do things like evasion attacks, or if it's run internally, somewhere where the network is protected, or it's completely different set of possible attacks if we are talking about on-device method that goes around, maybe device is available to other people, or in cloud. And all of these things should be considered from the very beginning. So it is too late when you already have a model based on super complex deep learning and like many things to do, and then you say, okay, now I need to put it on device. So it's too late. And finally, there is in recent years a very good paper that essentially stressed the topic of costly maintenance. It is a paper published by Google. And in this paper, they really revealed the real expense, the real cost of putting these super complex machine learning models in production. And I strongly advise that if you are doing something with machine learning in production, it's really useful to read this paper and understand now why we should not go with thousands of features into deployment, because among other things, we need to later track all these 1,000 features. When one of them changes, what do we do? Do we redeploy the model? Do we remove it? What is the performance then, and so on? So all of these things are things to have in mind. And now, just quickly, I'll go into these are now my last couple of slides. I just want to show you that there was a recent paper that was essentially, that got Distinguished Paper Award from Usenix that showed that many top research papers dealing with machine learning and security essentially suffer from all kinds of pitfalls. Like some of them we mentioned here, like problems with labels, sampling data, evaluation only in lab. If you're interested in the topic, please check out this paper. It's very good. And the point here is that these pitfalls are prevalent even in this top research. And if this is the case, then this happens with peer-reviewed papers where people also try to actively contribute code and data sets and so on. It certainly also happens within our own internally developed industrial solutions. And it is really important that we think about these problems and try to resolve it also on our industrial wide scale. And finally, just to now wrap up this part, and I hope that timing is still okay. So in this previous 20 minutes and so, I tried to share with you that AI is really important for security. It is a promising and highly beneficial tool that brings a lot of values and is doing things that we previously could not imagine. But at the same time is essentially a tool that comes with some inherent problems, and it has own weaknesses that with time we are understanding more and more. And essentially, as practitioners of machine learning, we need to know about them. And finally, to successfully develop solutions based on machine learning, we really need to constantly learn and expose ourselves to new knowledge from different domains and be aware of best practices and finally include them in the systems we design. And with this, I basically finish my presentation, and I hope there are a couple of questions. I'm sorry that I'm not there, but if you have questions, I would be more than happy to hear them now.
So, thanks a lot. Can you hear me?
Yep, absolutely.
Yeah, perfect. We have some questions from the audience, and I will start with the first one. How can machine learning be applied to avoid false positive findings in SAST tools, in static application security testing tools?
It's a good question. I think the big problem is really this avoid false positives, because this is the core problem of machine learning, and especially when we have such a highly unbalanced data sets, then false positives really matter. And even what in all other domains would be considered low false positives, within security application, these are essentially high. So I think I don't have let's say a way now to say this is how, but I do believe that the more data we have, the more knowledge we are building about the problem, we can essentially develop better methods. And that for me are how usually the discussions on how to develop methods for security go, is how can we develop representative enough big data sets, ideally also shared, that reflect this problem very well.
Then we have some questions about how you would get started with being involved with AI. So as a company, are there some low-hanging fruits that you can start with in security? What would you suggest as a starting project?
Okay, it's a very interesting question. I somehow assume that there kind of many people are already like super proficient with AI, but yes, it's also a good question how to start. I think it's really important to do some specific use case scenarios. So to start maybe slowly with some specific problems and say, well, can I solve this problem other ways? And if not, well, let's give it a chance to machine learning or AI. And then through maybe having this super specific problem, then you can control much better what happens. You can collect representative data for this problem. You can create some baseline, maybe using a simple decision tree and trying to understand, okay, am I on a good path here? Is my decision tree picking up on some interesting features that me as someone who knows about this domain consider important? So starting in this way with simpler methods, explainable, maybe trees and so on, and then with time build on essentially every aspect of complexity of the method, but also the more data, also looking into more than explainability methods. What are my models learning? What are my models studying? And then hopefully arriving to the point in which the machine learning performance is better than the baseline of what otherwise you could do, maybe with some rules or with manual inspection or in other ways that so far you use for the same problem.
Thanks a lot. We have one last question because we have to go to the lunch break then. What's usually the source data of those models? Logs, network artifacts, or other entities?
Okay, so it depends in the sense that there is a scarcity of data. So everything that is available, people use. So publicly available, there are some couple of data sets that are essentially logs of traffic. But with time, people also say, well, okay, I processed these logs, I extracted these features. So then people follow up taking these features already as raw data, either from some CSV or things like this. So basically, all of this data is being analyzed in its different way. I see now more and more the topic of logs as they are being analyzed through natural language processing methods. So this is maybe something that is rising now on the horizon, but before essentially everything that people thought could be useful and essentially everything that as a practitioner you anyhow use was analyzed. And this totally makes sense because if me as human look into network trace, if I look into artifacts, if I look into logs, if I look into this and that, well, let's give also that information to machine learning and let's see what this method can do automatically with this available data.
Perfect. Thanks a lot, Jelena. Get well soon. One more applause for Jelena. Thanks a lot.
Thank you.
Thank you. Thank you very much. And thanks for staying with me just before lunch. I know it's hard and your stomachs are empty. So final thanks and all the best. Looking forward to meeting you at some other conference, hopefully.
Hopefully, yes.